Okay, so I will start my today's coding practice. So today's question is this one. Longest increasing path in a matrix. So I will give an m by n integers matrix and return the ranks of the longest increasing path in the matrix. Yeah. From each cell, you can easily move in four directions, left, right, up, or down. You may not move diagonally or move outside the boundary. Wrap around is not allowed. Okay. And seems like I can move to the same cell multiple times, I guess. Oh, no, no, no. It isn't possible because the path always have to be increasing. So it isn't possible that I come back. I see. And there are not 3 by 3, no, n by n. So, okay. So I see. So one possible, oh, maybe result, let me clarify my understanding of this question statement. So yeah, I will be given the matrix and I can start from any cell in the matrix. Yeah. And the matrix is, yeah, row and column is at least one. There is at least one row or column, so it cannot be the empty cell, empty grid. Okay, and all of them are integers. Let's see. Hmm. Okay, I understood. Okay, good. So let me think of the approaches I can take. So firstly, a kind of brute force approach is I start from every, yeah, cell, and then I try to move. I mean, I kind of do the every possible way. And in that case, it will take the factorial over 9. Because, no, 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 sorry. The factorial of m by n, maybe? Or I can say, from each cell, there are almost four directions I can move. So maybe 4 to the power of mn. So that's the time complexity. Maybe the upper bound, I guess. But obviously it takes too much time because M and N are at max 200. So let me see. So the thing I can say here is that I think I can do the memoization because when I start from say 6 here, um, I have only this way. And it doesn't matter which way I take to I mean, the path before 6, I mean 1, 2, isn't affected by which way I take. Because after 6, I always take the numbers which are bigger than 6. So non, I mean, it out of the business for smaller numbers, 2 and 1. So I can say, yeah, in that sense, I can use the memorization. So let me think with this example. So I will take a look at the biggest number, and I can say the longest path which is here is 1. And for this, this is also 1. And then I will take a look at, say, 8. And I can say, because there isn't any number larger than 8 around this 8, so this is 1. And then I will take a look at 6, and I will see the numbers around here. So here I'm taking a look in numbers. I mean, I'm taking a look at numbers in descending order. Yeah. And for 6, I have 6, 1, 8, 9, and numbers branches on 6 is 8 and 1. No, 8 and 9. And in either way, it will take ranks would be 2. And then I will take a look at this. And this is also 2. Yeah. Because the only number which is branches on 6 is 9. Then I will take a look at this 2. Then I find that the 6 is Rogers, so it will be 3. Then I will take a look at number 1. It doesn't matter which one I take earlier. Take first out of two ones because both of them are the same and they don't have the dependency to each other. So when I take a look at this will also wait. This should be 2 plus 1 is 3. And this one should be 3 plus 1 is 4. And for this one, Raja number is only 8, so this should be 1 plus minus 2. So in this, oh, I forgot to take a look at this, but this is only 1. Because numbers around 4 is 8 and 9, which both of them are larger than 4. Okay, so that being said, oh, the problem is I have to return the increasing path. So after finding the way, I will take a look and track from number 1, and then I will take a look at the number which is around here and which is larger than this one and whose longest ranks is 4 minus 1 is 3 because I have to take the numbers in the se sequence of number which I tracked first. Okay, so I think that's the main approach I can take. So because I took a look at numbers in, descending order, so I have to sort it first. This will take mn log mn to sort numbers. Then what I have to do is track each number, so it will take mn, and then also after finding these numbers, longest path numbers, I will track it again from from this one. So it will take mn. So in total, this will take log mn. mn times log mn. For space complexity, for the sorting, it will take mn, because in Python, it uses a temp sort, which is this external space of O of n and mn. And also, yeah, because I have to keep track of this longest path, which is in the parentheses, which will take mn, another grid, which is the same size as the given grid. Then, yeah, also I will be initializing an appending element to the returned array, but I don't count it in. So it will take O of mn. Yep. So okay, let me write the implementation. So first three, what I should do is I have to sort the numbers in the So first I will do the sorting part. So here I initiated the cells array and then put the table of cell value, I mean negative cell value, and then row and column. I did it with negative because in Python, standard library sort, this is always sorted with, I mean, ascending order. Oh, sorry. I will use the reverse keyword to avoid this. So with this reverse keyword, numbers are sorted by the descending order. So in this case, the largest value would be taken, comes first. Okay, then, so this is the, you know, matrix which stores the longest path from that cell. So what do you mean? So non-surviving, so in this way, I initiate the empty matrix. Yeah. Then what I do next is traverse, I mean, each cell in descending order. So for value, value doesn't matter. And for row, column, in there's then I need to take a look at the adjacent cells. So for row diff, so firstly I have to take care is if when it's the adjacent row is the adjacent column is C plus C diff. And the first thing I have to do is if this adjacent cell is out of the board, I have to ignore it. Yeah, so in this case, I will ignore. And the next thing, oh, let me, so, okay. So let me say the length of this is currently 1. This is a case when, say, in this example, when this is 4, there is no adjacent cell, which with, I mean, which can take the longest, I mean, following path. So as the default, I put 1 here. And if there is the one which takes longer, which, yeah, achieves the longer path, I will update this max length variable. And also, if the adjacent cell value is not larger than this current cell, I can ignore that. It ignores the cell. So Otherwise, I can take a look at this adjacent cell as the kind of candidate of the longest path from this cell. So max length is then after that, what I should do is because now I've found the maximum length, I will put it in the max length matrix. So in this way, I can find the max length. And the next thing I have to do is let me quickly comment it. So the first thing I have to do is find the starting point. Oh, one of my question is maybe there can be multiple paths I can take. In that case, what should I return? Return the wrong length. Oh, sorry. I have to return the length of the longest increasing path. So I don't have to return the path. So yeah, simply I can say I can return max um yeah. So this is how I can get the maximum length, maximum value in the max length matrix. Even though it takes some space, because in this inner, yeah, array would be the length of columns, I guess. Yeah, which is n, but it doesn't matter because space complexity is already O of mn. So I took this approach to get the maximum value in this matrix. Okay, so let me walk through my code quickly. Oh, so I will think of the smallest one, more smaller one. 9, 2, 1. Okay, so let me walk through with this code. Oh, this isn't so interesting. Yeah, let me walk through this code. So first thing I will get is length of the rows and length of the columns. So it should be 2 and 2. And then I will put values in the cells array, which should be so value, which is 1, 0, 0. And then the next, I mean, in the same row, which should be 0, 1, 3. Row is 0, column is 1, and also column is 1, row is 0, which is 2, and then row column is 1, 1, then the cell value is 3, 4. Okay, then this is sorted. So by the first element, so this should be 4, 1, 1 comes first, Then 301 comes next, and 100 comes at the end, as the end. Then the max strength array, matrix is initiated with none for now. Yeah. Then what comes next is for row column cells. So yeah, this iteration will take a look at these numbers. So firstly, I will take a look at the row column 1, 1, and I will take a look at the adjacent cells. And so for 1, 1, row column is 1, 1. So in this case, if this is 1, 1, this should be 2 and 1. Let me compute all of the possible adjacent row adjacent column first. Yeah. Or if this is -1, this should be, so this should, I started with 1, 1. So 1. So this should be firstly, oh, sorry. So this should be 1, -1, 0, 0. So 1, -1, 0, 0. And this should be 0, 0, 1, -1. So 0, 0, -1, no, +1. 0, 0, +1, -1. Yep, this one. So let me take a look. So when I'm at 1, 1 here, adjacent cell would be 2, 0. Oh, no, sorry, 2, 1. Yes, this one. No, no, no. 2, 0, 1, 2, 0, 1 here, which is as the bound. 0, 1, which is 3, yes. And 1, 2, which is out of the bound. And also 1, 0, which is 2. Yes, so 2, 3 are included, and other two are out of the bound. And they are, thrown away in line 47, 48, because rows and columns are 2, so it should adjacent column has to be 0 to 1. But yeah, if they are 2, they are, cancelled. Ignored. Then in line 47, I will take a look at matrix adjacent row adjacent column, which are 2 or 3. Both of them are smaller than row column, column cell, which is 4. So this is in line 49. All of the surrounding numbers are ignored. Then max length would be, okay, I found a mistake. So here. Oh, no, no, no. Okay. So, sorry, this line 51 doesn't happen in this case. So in line 53, I will put max length 1 to the max length array. So it continues in this way. And finally, I omit the continuous, walking through because it takes too much time. But finally, I will return the maximum value in the max length in this way. I'm pretty sure this is correct. Okay, let me run my code. Sorry. Because I have to iterate from 0 to columns, so I have to use range. Let me take a look at the other for loop quickly. This one is okay. This one is okay. This one is okay. Yes, okay. Good. And I will submit my code. Okay, good. So let me quickly take a look at it. The editorial of MN. Yeah, all of them are O of MN time complexity. So yeah, I can say this solution is one of the fastest. Um, yeah, I mean, optimized implementation in terms of the time complexity in bigger notation. Okay, so let me quickly wrap up. So in this question, I found the longest length of the path in the matrix. Yeah, and this question wasn't so, complicated. It's quite simple. And what I did was, I mean, I took a look at cells in descending orders on the values on each cell. And for each cell, I mean, I created another matrix which keeps track of the longest path from that cell. Yeah. And then I used it to, I filled the Max Planck's cell one by one in, yeah, the descending order of the original cell's values. Yeah, so that's the kind of approach I took. And yeah, so that was how I solved this question. Okay, so I finished my today's coding practice with this. Okay, so thank you so much. Bye.